Hello, I'm going to demonstrate projectile motion. With projectile motion we have an object that travels through space, and we're going to neglect air resistance for this discussion. And we notice that when we neglect air resistance, that the motion in the horizontal direction remains constant. That is, the velocity in the horizontal direction remains constant. The velocity in the vertical direction changes at a constant rate equal to the acceleration due to gravity, 32 feet per second per second. We combine these two velocities, the horizontal component of velocity and the vertical component of velocity, to give us the total velocity at any particular point in the path. Here the initial velocity tangent to the path is in this direction. We call that v sub 0. At the top of the path, the velocity has this value. After it gets back down to the same elevation, the final velocity has the same magnitude as the initial velocity. The horizontal component of the velocity remains constant throughout the path, and in fact at the top of the path the total velocity is the horizontal velocity because it has zero component in the vertical direction. To demonstrate that, I have a little ball here, and if I throw the ball through space, neglecting air resistance, the ball will follow that kind of a path. If I were to throw the ball a little bit faster, I would need to have longer arms, or I can throw it from this end of the table to that end of the table, and imagine that the ball starts here with a certain velocity. Up at the top of the path, it'll be moving horizontally with zero velocity in the vertical direction, and when it comes back down to the table on the other end, its velocity will have the value shown in the diagram. Projectile motion.